Imagine for a moment a behemoth from the cosmos hurtling towards Earth. What would happen if a huge asteroid struck our planet today? Let's delve into this hypothetical scenario, a fascinating yet terrifying thought experiment. Picture an asteroid, a celestial body composed of rock and metal floating aimlessly in the vast expanses of space. These cosmic wanderers vary greatly in size, from tiny pebbles to colossal mountains, even reaching up to a staggering 50 miles in diameter. Now imagine one of these celestial giants, say the size of Mount Everest, setting its course towards our blue planet. Such an event, while incredibly rare, isn't entirely out of the realm of possibility. The cosmos is a playground of unpredictability, and these celestial bodies are its most capricious players. The moment of impact would be an event of unimaginable scale and destruction. The asteroid, traveling at speeds of tens of thousands of miles per hour, would strike with an energy equivalent to billions of atomic bombs. The immediate vicinity of the impact would be obliterated instantaneously, leaving behind a crater many miles wide. But the destruction wouldn't stop there. The force of the impact would send shockwaves rippling across the planet, causing earthquakes and tsunamis of unprecedented magnitude. The sky would darken as dust and debris, thrown up by the impact, blanket the atmosphere, plunging the Earth into a long, cold winter. The catastrophic consequences of such an event are hard to comprehend. Entire cities would be wiped off the map, ecosystems would be disrupted, and the world as we know it would change in the blink of an eye. Yet even in the face of such a catastrophic event, there's an element of awe and wonder to it. The sheer scale, the raw power of nature on display is a humbling reminder of our place in the cosmos. With the spectre of such a catastrophic event looming, it's crucial to understand the science behind it. But for now, let this thought linger. Our existence, in the grand scheme of things, is but a fleeting moment in the cosmic dance of celestial bodies. Asteroids, these celestial nomads, have the potential to unleash unimaginable destruction. But what exactly transpires when they collide with Earth? Let's break it down. An asteroid's impact is influenced by several factors: its velocity, mass, and the angle at which it collides with our planet. The faster and heavier the asteroid, the more catastrophic the impact. The angle of impact also plays a significant role, with a direct hit causing more damage than a glancing blow. But why do these factors matter? Well, it's all due to a scientific principle known as kinetic energy. In simple terms, kinetic energy is the energy an object possesses due to its motion. The higher the speed and the greater the mass of an object, the more kinetic energy it carries. So when an asteroid hurtles towards Earth at breakneck speeds, it's not just a chunk of rock. It's a massive, high-speed bundle of kinetic energy. Now imagine this kinetic energy being suddenly released upon impact. The result is a shockwave that radiates outwards, obliterating everything in its path. The ground beneath the impact site is vaporized, creating a massive crater, while the surrounding area is flattened by the force of the shockwave. The energy release can be so intense that it's equivalent to multiple nuclear bombs detonating simultaneously. The angle of impact also plays a crucial role in determining the extent of the destruction. A steep angle of impact will cause the asteroid to penetrate deeper into the Earth's crust, resulting in a smaller but more devastating blast. Conversely, a shallow angle of impact will cause the asteroid to explode closer to the surface, resulting in a larger but less intense blast. This, in a nutshell, is the science behind an asteroid impact. It's a complex interplay of velocity, mass, kinetic energy, and angle of impact that determines the scale of the catastrophe. Now that we've grasped the fundamentals of an asteroid impact, let's delve into the possible consequences. The moment an asteroid strikes, it would set off a chain reaction of catastrophic events. But what are they, you might ask? Well, let's delve into the nitty-gritty of this cosmic cataclysm. In the immediate aftermath of an asteroid impact, the first thing we'd notice is the creation of a massive impact crater. This mammoth hole would be the result of the immense kinetic energy released upon impact, equivalent to billions of atomic bombs. The sheer force would vaporize the asteroid and a large portion of the Earth's crust at the impact site, creating a fiery mushroom cloud that would stretch into the stratosphere. But the impact crater is just the beginning. The energy released would also cause an ejection of debris, hurling millions of tons of Earth's crust into the atmosphere and beyond. This debris would rain down across the globe, igniting wildfires and causing widespread destruction. Moving on to the secondary effects, the aftermath could trigger tsunamis, especially if the impact occurred in the ocean. These gigantic waves, reaching heights of hundreds of feet, would wreak havoc on coastal regions, obliterating cities and causing untold loss of life. Firestorms would be another consequence. The heat from the impact and the ensuing wildfires would create powerful winds that could fan the flames, causing firestorms that would incinerate everything in their path. And then there's the possibility of an impact winter. The debris ejected into the atmosphere would block out the sun, causing a drastic drop in temperatures worldwide. This could lead to a global winter that could last for years, decimating plant life, disrupting ecosystems, and potentially leading to mass extinctions. In short, the aftermath of an asteroid impact would be a sequence of devastating events, each more destructive than the last. From the initial impact crater to the ensuing tsunamis, firestorms, and impact winter, the Earth would be transformed into a hostile, unrecognizable world. From immediate devastation to long-term climatic changes, the aftermath of an asteroid impact could be dire indeed. Earth's history bears testimony to the devastating effects of asteroid impacts. Let's take a journey back in time. Our planet's past is dotted with cosmic encounters, some of which have left indelible marks on the course of life. One such event is the infamous Chicxulub impact. Occurring approximately 66 million years ago, this is the asteroid strike that many scientists believe led to the extinction of the dinosaurs. Named after the town near where it struck in the Yucatan Peninsula of Mexico, the Chicxulub impact was about 6 miles wide, creating an impact crater over 100 miles in diameter and 20 miles deep. The evidence for this impact is found in a thin layer of sediment worldwide, known as the KT boundary, filled with high levels of iridium, a metal more abundant in asteroids than on Earth. This layer also contains small droplets of rock that were melted by the impact and then solidified in mid-air, as well as tiny grains of shocked quartz, which forms under extreme pressure. Another significant asteroid event in Earth's history occurred in 1908 in Tunguska, Siberia. Unlike the Chicxulub impact, the Tunguska event didn't leave a visible crater. Instead, the asteroid, estimated to be about 120 feet wide, exploded in the atmosphere with the force of 1,000 Hiroshima bombs, flattening about 800 square miles of forest. This event is a testament to the potential destructive power of even relatively small asteroids. The evidence for the Tunguska event comes from eyewitness accounts, photographs of the flattened trees, and later, studies of the affected trees' growth rings. From these historical events, it's clear that asteroid impacts have played a significant role in shaping our planet's history. They've caused mass extinctions and climate change, and have left their mark in the geologic record. These historical impacts underline the potential threat asteroids pose to our planet. While asteroid impacts are rare, the question remains, are we prepared if one were to happen today? In the vast expanse of space, countless asteroids hurtle through the void, some of them passing uncomfortably close to our pale blue dot. But fear not, for we are not entirely defenseless in the face of these celestial speedsters. As we speak, scientists across the globe are tirelessly working on strategies to detect and deflect these potential planet-pummeling projectiles. These include radar systems, space telescopes, and even spacecraft designed to nudge threatening asteroids off their collision course with Earth. NASA, the United States Space Agency, has a division dedicated to this cause, aptly named the Planetary Defense Coordination Office. Their primary objective is to detect, track, and characterize near-Earth objects, or NEOs as they're often called. These are asteroids and comets that could potentially come within 5 million miles of Earth. But the efforts are not confined to the United States alone. Across the pond, the European Space Agency, or ESA, has a similar program known as the Space Situational Awareness Program. This initiative also focuses on identifying and tracking NEOs, demonstrating that the task of protecting Earth is a truly international endeavour. In addition, there are numerous international collaborations, such as the International Asteroid Warning Network, a group of organisations from around the world committed to detecting, tracking and characterising potential hazardous asteroids. And let's not forget about the private sector. Companies like SpaceX and Blue Origin are pioneering technologies that could someday be used to alter the course of a threatening asteroid. So, while the threat of an asteroid impact may seem scary, it's comforting to know that there are dedicated individuals and organizations out there constantly scanning the skies, ready to spring into action should the need arise. Unpredictable and potentially devastating asteroid impacts are a cosmic threat we must prepare for. After all, forewarned is forearmed.